The next one I'm going to do is one of the squeeze theorem ones, where we wanted to find the answer to this problem here. Now, the issue that we get when we plug in 0 is that we get to divide by 0. So we know that something else needs to be done with this. Whenever you see a trig function here, it's a good idea to try to use the squeeze theorem if you can. So the squeeze theorem tells us that we need to make this function here be squeezed in between two other functions in order to find the limit. Because if the limit of the lower bound is equal to the limit of the upper bound, then everything in between it, including the limit of this function, has to exist and be that number. What you want to notice here is first, you always want to take your trig value, or your trig function, okay, and this is the equality that you want to create for that. You always know that any trig function has to be between -1 and 1, just a regular trig function. And the reason is that can be seen from the unit circle. You know that no matter what value you would plug in for sine or cosine, you're never going to get anything more than 1 and nothing less than -1. Anything in between. So now that we have this hard boundary, you can start working with that to get to this other part. So if I know that cosine of x is any value between -1 and 1, the cosine of 2 over x is also going to be any value between -1 and 1. And the reason for that is that no matter what you do to the inside here, as long as it's only a cosine or a sine on the outside and nothing else, it's always going to be between -1 and 1. So in this case, it's also acceptable to say that equality holds true as well. Because of this one, we know that this is also true. Now the next thing we need to do, we want to make this inside function look like this one so we can get it squeezed in between these two. So the next one you want to do is multiply by an x cubed on both sides. So now that we see this, we know that our function here is squeezed in between these two functions, and we can find the limit as x approaches 0. Okay, so we take the limit as x approaches 0 of this one. We're going to plug in 0 and get 0 for that. We're going to take the limit as x approaches 0 for this guy over here, plug in 0. You're going to also similarly get 0. So since the limit as x approaches 0 on these two guys is 0, and this function is in between these two functions, we know that the limit as x approaches 0 of this one also has to be 0. So we know that this is true. Now this can be shown graphically because here I've got an x cubed, which is going to look something like this. And on here I have a negative x cubed, so it's going to look something like this. And then in between those two functions I have some value here that we don't know about. Some kind of squiggly something or other, maybe it looks something like this. I don't have any idea really. But what you do know is that right here it's squeezed in between these two functions and it has to be 0 at that point because the limit as x approaches 0 is 0 for both of them.